Well, I'll try to keep the explanation to a minimum on these questions. To find the position, just plug in t is equal to 5 seconds. To find the velocity, take the derivative with respect to time. And then plug in t as 5 seconds. To find the acceleration, take the second derivative. This question can be done using two equations. Both the final and initial velocities are unknown. That's equation 1. And this could be the second equation used. Now it's just a matter of solving the two equations. I have substituted 1 into 2. VF is negative because A is negative. I had forgotten that. In this question, there are two players. One is moving at 12 meters per second, constant velocity. The other one starts from rest and moves with an acceleration of 4 meters per second squared. By the time this guy starts off, the other one has already moved 36 meters. Counting the time from when he begins to move, we know that both will take the same time. And, equation 1 gives the displacement of the first one, who starts off from rest, and this equation 2 of the one who's moving at constant velocity. But yet, now this is an important step. x1 is x2 plus 36. Substitute that and solve the equation for t. There's going to be two results for the time. Take the positive, substitute back into equation 1 to get x1, 134 meters. In this problem, the initial velocity is to be found. Since it's thrown up, A is negative, delta y is 4 meters, and delta t is 1.5 seconds. Solve this equation to get VI. (10 meters per second). The second part, got to find the velocity of the keys just before they were caught. Remember, the negative shows that the keys were caught on the way down. 5, that's how the dog moved. First to the south, then northeast, and then to the west. In number 6, please change the question to north of east. Change the question to north of east. Straightforward question. Just take the two components and put them together. That is the unit vector expression. In 7, the initial vertical velocity is 0 and delta y is 1.22. So use the equation to calculate time. And then you know that the horizontal displacement is Vx delta t, from which you can find the horizontal component of velocity. It's 2.8 meter per second. And then to find the direction of the velocity before it hits the floor, find the final vertical component. And then take the tan theta. 60.2 degrees. The ball is 36 meters away and the crossbar is 3.05 meter. So the initial velocity 20 can be resolved into 20 cos 53, which is the horizontal component, and since horizontal displacement is horizontal velocity by time, we can find the time as 3 seconds. And then the vertical component is 20 sine 53, which is 16. Then use this equation to find delta y as negative 3.9 meter. That means the ball clears the bar by 0.85 meter. Now, the negative shows that it was on its way down. In this case, the electron has mass and speed is given. Both its initial and final speeds and the distance given. Got to find the acceleration. Use this equation. And from the acceleration we can find the force. Now the weight of the electron is just mg. Question 10 is about rotational motion, and it is the force of static friction that keeps the coin on the turntable. Centripetal force should be equal to force of friction, which is mu Fn, and Fn is mg, so mu is 0.085. Here the kinetic energy of the bullet, which is always half mv squared, and that should be equal to the work done. Make force the subject, substitute. So that's the force applied. And then the acceleration is force by mass. And the final velocity is vi plus at, from which we can find the time. The crate is pulled up a rough inclined plane, and those are the forces that act on it. The weight acts vertically down. You can see the normal reaction. Friction is downwards, and the force acting upwards, 100 Newton, is also shown. Work is here. You got to be careful because you got to find the work done by the gravitational force. The gravitational force is acting down, and the motion is along the plane, and the angle between them is 110 degrees. That's why it's mg cos 110 times 5. Negative 167.5 joules. The normal force is mg cos 20. The force of friction is mu times Fn. And the increase in internal energy is because of friction. Therefore, just find the work against friction. That's 184 joules. Change in kinetic energy is the difference between the two So when you take all those, you get 148 joules. After being pulled 5 meters, the total kinetic energy is 1/2 m times velocity squared. And you get 159.25 joules. Set this equal to the velocity. and you get the velocity. Impulse is given by those two formulas. Remember that the ball was moving along the X, along the I, and then it's hit along the J. So that's why VI is 45I, but VF is 55J. Time is given, the mass is given. Now, so force is calculated using that equation. Plug in the numbers. That is the answer. Here the final angular velocity is 98. To find the angular acceleration, time given. The total angle covered during the 37 revolutions is 2 pi times 37, because the angle in one rotation is 2 pi. Use this equation. Omega I is the subject. Now we can use this equation to find alpha. .67 radians per second squared. .15 is about angular momentum. Two parts to the question. In the first case, the moment of inertia is mr squared. That is the moment of inertia of that mass, which is attached to the meter stick. Angular momentum is I omega. In the second part, you find the moment of inertia of both, add them up, and you get the total, and then multiplied by omega. .16, the ladder is kept leaning against the wall, and those are the forces that are shown. The weight, 500 Newton, acts down through the center. 800 Newton is the weight of the firefighter. Fx and Fy are the forces at the ground there. And the important thing is to take the torque about the point touching the ground, about O. So that will be 800 times 4 cos 60. The idea is you take 800 times that distance plus 500 times this distance, because you're always calculating the distance from the pivot, which is O. And also notice that there are two clockwise torques due to 500 and 800, and there is one counterclockwise. The counterclockwise one is the one at the top here. Fy and Fx do not contribute to the torque because the distance is 0. Total upward force is equal to total downward, and Fx should be equal to Fw. In the B part, the ladder is just about to slip, and so the torques are calculated again. From which Fx and Fy can be calculated. Therefore, coefficient of friction is 421.5 by 1300. 17, just a straightforward question to calculate the increase in length from the Young's modulus. That gives the increase in length. 18, the satellite is orbiting at 100 kilometers. That is the formula for total energy. Just trying to show how that was obtained on the right side. That will be the change in energy, because you're asked to find how much energy must be added to the system. To take it from 100 to 200, so that's 1 by 10 to the 5 and 2 times 10 to the 5, changing both into meters, that's why. So it's 1.99 times 10 to the 12. Just a matter of finding the pressure due to the two columns and adding them up. Add the atmospheric pressure plus pressure due to the oil column, and then find the pressure at the bottom, which will be the sum of this plus the pressure due to the water column. $20 is about oscillation of a spring with a mass attached. And the total energy is given, and total energy is 1/2 Ka squared. Also, you can find omega. From omega, we can find K. and then plug it back into the first equation. Make A the subject, because we're asked to find the amplitude. And we can find the maximum speed by setting the kinetic energy equal to the total energy. 21. Volume given. Change it into meter cube. Temperature is 500 degrees Celsius. Molecular mass of H2O 18 grams. And since we have 9 grams, the number of moles is going to be 0.5. Use PV is equal to nRT. .61 megapascals. 22. That is the expansivity of brass. From the expression for time period, we can find the length of the pendulum. So knowing the original length and alpha and the change in temperature, we can find the change in length. Now find the new time period. Now take the ratio of the change in time period so that'll be the time. So we get 36.3 minutes. Pressure given in atmosphere, so change it to Pascal. Volume given. And work in this case is PDV. So the final volume is 8. Take away the initial, that gives you the change in volume, and you get the work. And the second case, negative because the gas is being compressed. And the last question, that's the temperature of the low sink or the cold one. The hot one is at 293 Kelvin. The heat required to change water into ice first, water has to be cooled, so that's the heat required for cooling, and then the heat required for changing into ice. So we get the total heat, and then the coefficient of performance is given by that formula. And then using these coefficient of performance, you can calculate the work. Well, thank you. I'm sure that I went real fast through this, but as you know, you can pause and take a look at each problem and try to understand this for the final exam. Good luck.